calculator. Remember, you go to the home screen, 55, your first name, first initial from your first name, and your last name, password 1, 2, 3, 4. So let's start off with, now I'm not asking you to analyze it or show how you got there. Looking at that expression, who can tell me what it means? It's a sentence you're going to give. What's it mean by having that expression on your paper? You've got note takers, 2 of you? Oh, come on. More than 2 people in this room have got an idea of what the hell's going on. What do you want to say?
As a function, 1 plus x, 1 over x goes to 0, the y value gets closer to
Perfect. That's all it's saying. And to go through and give that, that's terrific. Let's go through, and now, instead of typing the whole thing out, I'm going to say this. So, as the input, or x value, approaches 0, the output of the function approaches the number e. I think that that's a pretty tight explanation. That's what it's telling you to do. Do we have questions on that? So much of what we do, and understand this, so much of what we do this year is going to push you algebraically, because the thing that makes calculus very difficult is, we're saying, all right, we're presupposing you get all of the algebra right. You know all of the algebra rules. Now we're going to apply new rules about graphs and about something that's a completely separate topic, but is constantly referencing the algebra. And this is more concept-based as opposed to algebra, which is computation, meaning I could give you 100 questions in a row, x plus 5 equals 3, solve it out. I give you 1,000 of those. This is really, let's analyze what's going on, what does the graph look like, etc. Now, that's what our answer would be for 1. Using calculus methods, find the horizontal asymptote or asymptotes of this. Now, keep in mind, this means 2 things, and some of you might be a little bit off. This is asking what the limit is going to, because we're talking about horizontal asymptotes. Here's a horizontal line, and some of us become a little bit, I think the word's myopic, when you're just focused on one thing, you don't see anything around you. If this is what we're looking at to find a horizontal asymptote, you all probably did, what's the function doing to you as we go to infinity? Is that fair to say? What's wrong with what I just said? You got to go to positive and negative infinity. So we're going to technically have to do 2 things in order to answer this out. We've got to go to the left and to the right. So to start this off, I'd say, now I'm going to shorten this up. The limit is x approaches positive infinity of the function as a whole, because that's what the function is defined as. This is the same as, or going to give the same answer as, the limit as x approaches positive infinity of what's governing the behavior of the f of x, or what reduced out expression, I guess, could we look at to determine what our end behavior model is going to be. We got 1 person that can tell me, 2. We're better than that. What? Now, that's what's driving the numerator, and that's what's driving the denominator. So we've got this. And what is that going to then, Noah? So we can go through and say this has a horizontal asymptote of y equals 1/4 as x goes to positive infinity. That might be more than normal. Now, some of you are going to say, well, we did the same thing with negative. Analyze each situation. Once you get a 5 on the exam, you can come back with complaints. Let's look now and take the limit as we go to the other side, which is the negative infinity of our function. Our end behavior model is going to look profoundly similar. It's still going to be 2x squared over 8x squared. What is that limit going to be? Think about what happens when I put huge negative numbers in there. It's going to be the same thing. Why isn't this expression going to be negative? Because the x is squared. Now, if it was cubed, What happens when you take a negative and cube it? It's a negative. So do they always match? No. You have to analyze and think of every possible outcome. So we're going to have another horizontal asymptote. It's at y is equal to 1/4 as x goes to negative infinity, which means, by the way, how many horizontal asymptotes are there? You could say that there's 2, but the argument can be made there's 1 because it goes to the same thing as you go out to positive and negative infinity. Questions on that? Now here's one piece that I want you to analyze, because some of you gave up on us on this one, or just became a lazy Larry and said, we'll go over it later. Look at this graph here. You got a rational expression. You're asked to find that limit. So before we become addicted to the calculator, process what's going on. I'm going to graph this out. Now, you know something that this graph is going to have. Does anybody want to tell me one characteristic of this graph? Yeah. No, there won't be a hole in the graph because there's not a factor that matches that reduces out. There's a vertical asymptote at x is equal to 5. Now, I don't want to ruin it. Odds are, we're going to ask you to take the limit where there's a problem area, just so you know. Looking at what's there, oh, shockingly now, we're taking the limit as x approaches 5 from the positive side, which means as I come at this from the right-hand side. So, I need to figure out, now keep in mind, this is sort of like a force field here. So the graph is either going to sort of ride along, and it's either going to pop up or pop down. How can you figure out which direction it's going to pop into? How about we do this? Now, let's say I took the calculator away from it. As I approach it, this would be 5 and this is 6. I'm trying to find this local behavior. What's a number between 5 and 6 that kind of makes this easy to do? Let's try 5.5. Sure. Let's try 5.5. So 5.5 plus 5 over 5.5 minus 5. 5.5 plus 5, that's 10.5 over a half. So is this going to be going to positive infinity or negative infinity? Positive infinity. So the graph, you can tell, is going to shoot up here. Now, over here, if I did the same thing, it doesn't matter for this case. But what's a value I'd pick over here? Maybe negative 4.5, and you'd see that the graph trends like that. That's understanding what a rational graph is going to look like. Now, the answer to this is sort of twofold. Who can tell me one of the two possible answers I could give for 3? Positive infinity works. So I could say the limit as x approaches 5 from the positive side of x plus 5 over x minus 5 is going to be equal to, we could either say it's positive infinity, or what else could we say about, oh, wait, I'm sorry. There is not, because this is a one-sided limit. One-sided limits can go to positive infinity as an answer. It's a full limit that can, so keep that in mind as well. Some of you are probably going to say the limit doesn't exist. The limit doesn't exist if it's a one-sided limit and both of the ends of it are going to infinity. So keep that in mind. Questions on that one? Do this, well, you can go into your calculators right now if you wanted to and plug it in to get a good look of it, if the calculator is available to you. Now over here, I'm going to say the calculator isn't available to you. Look at the numerator and look at the denominator. Is it to negative infinity? Oh, even more terrific. Even more terrific. Looking at this, normally you'd say that these go to 1. Because it's the same in the numerator, same in the denominator. Who can tell me what that limit's going to as we go out to infinity? And give me a justification. Walk us through your logic. Why'd you say negative 1?
Because the numerator is going to be positive and the denominator is going to be
Well, you're right. As I go way out to the left, this numerator is going to be a positive value, this denominator is going to be a negative, and they're going to be the same value. One's positive, one's negative. That means that the expression overall is negative. If you graph it out, you're going to see that 1/2, everything to the right of the critical is going to be positive, everything to the left of it's going to be a negative 1. So questions on that? All right, let's bounce over, please, to your note packets. Oh, have out on your desks, please, right now, worksheet A, limit worksheet A. Make sure that your name is at the top and hand those up and over to John. Now, we're going to say this to you all nicely, and we'll preface it with, let's say, a vague compliment in there as well. As you hand those in, and understand the other thing that it said was worksheet B, you picked up worksheet B. If you didn't, there's ones over on the side. Look at that. It's worksheet B. It's the next one. It says when. We'll get to that in a second. But what I'm going to remind you all is this. It's imperative for your success. And literally, Miss Miller and I were talking about this 3 minutes ago. 3 minutes before the start of class. I sat there and I was like, you know, we really need to emphasize how important it is to have a study group. And you're going to find, you all, by the way, are old enough now, you're taking math as an elective. You are free to divorce us and leave anytime you would like. That's what makes me so excited that you're here. Because you could, like, I can't take my dog off of the leash ever, because he probably would be happy with literally any other person besides me based on how hard he runs towards the fence constantly. He wants to get away so badly. It's probably because I hug and kiss him too much. But what I'm going to tell you all is that you're here voluntarily. And what I want you to get, it's a life thing. You don't have to take this for AP credit in the least. You don't have to take it for MCC credit. I encourage you to take it for both. You don't have to do any of that. I get messages all the time from kids who go, yeah, you know what, I took this class and I failed terribly, but it was amazing. Because I went to college and took Calc 1 again, we got a 90. There's a kid that texted me. I don't even know how the hell he got my number. But all of a sudden it comes up and it says, I just got a 98.6 in Calc with the emoji that's like this, with some two hand things. I thought there was anyone that got a field goal, that's not it. And I go, and then I'm like looking and I'm going on, who the hell's number is it? It was the guy I had the year before, out of the blue. University of Georgia, 98. They took the same course that you all are in now. So worst case scenario, you're ensuring that you'll do well next year. That's the worst case scenario. The reason that you have to, and I can't more strongly advise you to have study groups, is this. I asked Ms. Miller what her most successful kids did. And it was they came in and they did the work together in the room. You're free to come in here anytime you want. My schedule is up there. It's stopping the math there. It's too difficult to do this class alone. It really and truly is. You are going to find people and work with people. The hope is that you find people and work with people outside of your own social circle. Hopefully now you realize that pretty much all of high school is a baloney charade. Okay? I can assure you, there's so many people that were, I'll say this, one of the most popular girls from high school at Greece Arcadia, her face looks like shoe leather, because she went like tanning to the point of being obnoxious. It was very popular in the late 90s. And she works at Denny's. Okay? It's back-breaking work, but she, God forbid, she was popular in high school and she didn't learn a damn thing. The hope for you all is that you're going to go off to school, make something of yourself. You're going to find people you didn't think you got along with in high school, you get along with at college. Why not start that now? Find people around. My favorite moment was the moment last year where one girl walked up to a boy in class last year, and the boy was a little bit awkward if we were to put high school constraints on him. It's a little bit awkward. She goes, you answer the questions so much faster than the rest of us. Do you mind if we work together? You would have thought that the kid had said, do you make more friends when you're at college? Yes. But then it started for him, believe it or not, when he was in high school. And they formed a study group. And they were all successful. Because you have to find people to go through and work with. And understand, it's not copying from someone, it's legitimately working with. And it's when you get a worksheet and you're going through and you go, I did it this way, but you did it this way. Let's do both. Maybe we're going to get to the same answer. Maybe we're doing the same thing. Or, you know, it's this way or this way. We're going to hit the roadblock together. But you have to be willing to do that and take those chances. And I can't tell you, I want you to be so successful it's disgusting. I want you to do so well that they fire the calculus teachers at Thomas. That's my goal. So if you come back and you see that there's job openings for math teachers at Thomas, you'll know how well you did. Okay, that they just listed. You're done. You obviously can't be doing well. Look at how well the straight kids did. That's my hope. Now, but the other end of it is you got to do the work. And that doesn't mean, you form a group chat where everyone's copying. That was my favorite. It was so eye-opening for me. I'm sitting there going through this kid's phone, and it's like, yeah, this is our Calc group chat. I'm looking, and I'm like, oh my God, this is literally every page. And the worst part, one kid was doing it. One. But the fun part, the best part was, and they all were about the same. On the AP, he got a 5. Everyone else got a 21. You can't get a 21 on the AP. Okay? So if you actually do the work, you will be so successful. But if you're going to copy, we'll say it to you nicely, why bother? If you're not here to get something out of it, you can take, an extra lunch. Right? Are they still in lunch now still? You can think of all the cafeteria food here. Not one plate of pasta. 2. You could have 1/4 or 1. You probably want to let it linger. You can have some sorbet to cleanse your palate between courses. Now, you all have, let's go to the beginning. And if I forget to do this, please feel free to yell at me to go back and do it. We're going to start off. All right, so we're at this page now. You all picked up worksheet B. It is due on day 8. Limits to infinity. This is 9. What's today, kids? 9/13. All right. Do you have some questions for Math Excel? By the way, at about this point in the unit, we'll make it be this day here. You're going to, so before, actually we'll do it here, sorry. Before quiz 2.1 and 2.2, your first sort of major grade that we're going to have, the homework is going to get handed in. Your Math Excel is going to get handed in, the work that you go through and do. Like we said, do it out on separate. If it needs the justification, show it. There shouldn't be any math magic as to how the heck you got your answers. Okay? So, I advise you to keep it, another thing, if you keep it in a notebook and you rip it out from the side, personal pet peeve, there's thousands of them, but did I go over the tentacles on the side of the paper? No. If you need paper, if you take a look over on the side there, right near our class, showcase my Abby. You see, look at, see, you've got a career. Can you do that again, Chris? You've got a career. You could be on the Price is Right. That's how big you are. So, there's tons of paper over on the side. If you ever need it, you can take some. Don't take all of it, but take some of it. And make sure your homework is done, your Math Excel is done on separate paper. Don't wait until the end to go through and get it done. So that's your homework. You got 2 or 3 questions. Let's bounce over now. Slide 30. Okay, 29. Now, what we talked about last time was figuring out how many times these. We talked, about limits going out to infinity last time. We need to figure out how many times these graphs are going to go through and intersect. So do this. Now, why don't you go through, please. Try out that first example. Graph those 2, and let's see how many times that they overlap. Now, let's do this to start. Make sure, again, you all have logged in. Alright, so go in and you're going to put your 2 graphs in. Here's somebody who has done this correctly. For that first one up, you're going.
This equal to 1.01 raised to the.
Oh, it's 1.01 raised to the x. I'm sorry, that's right. It's 1.1 raised to the x, so if you can go, is it Control T? And then you can go through and edit it. It's 1.01 raised to the x power. Press enter. That's going to give you a little bit of a different graph. Now, what you have to notice, though, is what's happening as we get really, really big. What's going to end up happening is this. This graph, you would presuppose how many times do they intersect? 2, and you're wrong. If you don't understand relative growth rate, you're wrong. Which one of these, long term, is going to be on top? Does exponential grow faster than a base to a power? Yes, it does. So, at some point, if we go out to infinity, this red graph is going to pop up and over this one. Let's see if we can change it, please. By the way, I was at a seminar this weekend for the TI people, and he said this is a good way to remember. This is, hang on, I had to type it down in notes on this thing so I won't forget it. It's document-based and menu-driven. It's document-based and menu-driven, meaning if you need to do a new problem, you go to document. If you need to analyze the problem you're currently on, go to menu. Let's go to menu and let's see if we can go through and expand our graph out, because I always struggle whether it's menu or doc. Let's go in our window here so we can find out. Now let's change it up. We're going to go to Window Settings. Now, we're only going out to 10 and to negative 10. Where is this third intersection going to happen? Is it going to happen as I go out to positive infinity or negative infinity? Positive. So let's do this. Keep the x-min the same. Let's change our x max to be 1,000,000, which is 6 zeros. We don't know how many zeros in a million. It's tough to make that much money. Now, go to the max, and let's change the max to be 1,000,000 as well. Are we going to be able to see them go down to, okay, and maybe we won't see them. Maybe there's limitations on this. Who knows? But we'll give it a try. So I'm guessing that the intersection occurs before that, because everything is smashed over in here. So let's do this. Go back to the menu, go back to the window, and then 1. And let's change it so our x max is, let's say, 1,000 instead of 1,000,000. And maybe make that, keep that the same. Will we see it then? No? 1,000 and 1,000. All right, so let's go in. By the way, a shortcut, if you know the number, you can just hit the number. So you can hit 4, 1. And you're saying to change this to 1,000?
Yeah.
It's a little bit easier. You can see it or no?
Yeah, it goes.
Okay, so you see that does happen, though. Okay? So, when we get out of that, let's go back now to our worksheet for today. Which one of these, how many intersections do we get? They cross 3 times. Because remember, this graph, and it's talking about relative growth rate, one of them is going to go up. This graph sort of looks like this, but it levels off. This one here is going to go up, down, and then it's going to eventually overtake this green graph. I guess maybe if we extend it, it would sort of, it's not doing that in reality, but my graph is a little bit screwed up. But it would happen, so you get 3 intersections. And the next one up asks us to go through and analyze what's going to happen here. Go through and graph those 2, and let's see how many times they're going to cross. You may want to keep that window as it is. Oh, by the way, here's one thing that I learned too this weekend. Let's do this. Let's say hang on one second. Let's say I don't want to delete what I have here, but I want a new graph. I think that this is right. Go to Doc. Then go down. Is there a new problem one? Insert. I think if we go to, maybe is it insert? There was a thing. Problem, there we go. So 4.1. There you go. Now you're at 2.1, and you can reassign variables there. So now we can go through and graph the other one. That's a shortcut. Remember, you shouldn't be working in Scratchpad ever, because the stuff is stored locally, and it's not like we need to store values. Remember those intersections that we just found? I need to find that exact value and then use that in computations. If you're in Scratchpad, you can't save that number. You would literally, you'd be like, you know how 3.14 isn't the same as pi? Unless you're using the exact value of the intersection, you may not get the right answer. Okay? So, how many times do these graphs intersect? Well, you would normally guess how many times? 1. Which one is going to grow faster? A linear function with a positive slope or a log function? This initially grows faster. Over time, this grows faster. Because what does this slope go out to or start to approximate? Starting to approximate 0 as we go out to positive infinity. Never is 0, but it's getting less and less gradually rising. And this will overtake it. So at some point, we're going to have 2 times that these cross. So it's going to look like this. Here's my log graph. I'm going to try to use the blue like they did, so it would look like this. And over time, the red will go like this and then eventually overtake it. Even though it's got a profoundly small slope. Questions on that? Now what you all are going to do is consider relative growth rates and evaluate out this next subset here. Is it 6 questions? Finish out all of these right now. Analyze what's going on. Think about the numerator and denominator as we go out to positive infinity only. There's a negative? Oh, is it only the second one? Sorry, the second goes to negative infinity. And don't go to the calculator. Don't go to the calculator. Just so you know, on the AP exam, there's a calculator free section. You're actually going to dread the questions where they give you the calculator. They're 1,000 times more difficult. So be able to get this one done. Think about growth rate, which side's growing bigger, and what's that mean for the function's behavior. So let's look at our behaviors that we're going to get when we do this out. Who can tell me what we would get for the first one? Hands up, please, if you can tell me what that limit to infinity is going to be. We've got a linear function over e to the x. 0. Which side's growing faster, numerator or denominator? This next one is probably the most difficult one. Keep in mind you're plugging in a negative number. This is going to be the same as the limit as x goes to negative infinity. Now, when we're doing this, the function that you're going to get, this becomes, we'll say it this way, I guess, as we plug in, start plugging in negative values. The numerator of the fraction is going to be negative x, some negative value. Actually, maybe we'll do this. Instead of making it x, let's do just a negative number, all over e raised to a negative number. Now, before I go further, I need to ask myself one question. What can I do about this? It seems a little awkward that I write part of this out. What can you do? Is there something?
Like, kind of like E over the number.
No? Be careful, you're on the right track.
Bring the e to the negative number to the numerator.
Yeah, because if you have it, if the base is raised to a negative power on the current side of the fraction, when you move it to the other side, it's going to be positive. So this leads me to think this is going to be some negative number times e now to the positive number power. What does that mean my limit is going to? What kind of answer am I going to get? I'm plugging in huge values for it. Give me one second.
A really large negative number.
Perfect. So that means our answer would be negative infinity or does not exist. This is what Miss Miller and I were discussing, going, what does the AP give? She goes, they use both. Which is not subtle. Now, maybe we can do this one out, and I think that's the only negative one. What about for the third one? Which side is going to be growing faster? X to the 99 or e to the x as I plug in gigantic, colossal values? E to the x is growing larger. Believe it or not, this would be some small number over some huge number. So what does that mean that your limit is going to? 0. And by the way, when we talk about work, this, we wouldn't show this on a calculus exam, you'll laugh at you. Now, take a look at the next one. Hands up, please, if you can tell me what you'd give as an answer to that fourth one. Why? Which side's growing faster? Maybe I'll do not in equals but arrows. Which means it's going to go to positive infinity or does not exist. It depends on, because again, it's not going to a number. What about for the next one? Natural log of x over x to the 99. That numerator is going to grow really, really slow. How about the next one? Or what else could you say? How about for this next one? It does take a bit of analyzing. You really got to understand. This is a terrific question. It puts together a lot of stuff that we're presupposing that you know. Who's got an answer? You got one person.
It may still be 1/3.
As I start plugging in, what do you know about signs, values, we go up to positive infinity?
Stay around between 1 and 1.
What about cosine? Is that affecting the value of this as we go out to infinity? They're negligible. That leaves us with this. And then you got the number squared up top is 3 times the same number. This would give me a positive 1/3. You have to really look at piecing everything together. Questions on that? All right. Next one up. Now, these are going to get, well, this is still, relatively speaking, a pre-calc topic. That line, x equals a, is going to be what we call, if it looks like, this piggybacks off of what we talked about before. The line x equals a is called the vertical asymptote. If either the limit from the left or the right goes to positive or negative infinity. Be careful, a hole in the graph doesn't lead to an infinite limit. That should make sense. If there's a vertical asymptote, it's like a force field. The graph isn't going beyond it. But if you have a hole in the graph, a lot of times we'll get something and we'll graph it out and it'll be wholly continuous. It'll be continuous except for that one hole in that one little area. And of course, we probably ask you to take a limit as we go to that. Now, looking at what's there, maybe we can do, well, think about what the behavior of this graph here is going to be. Do we have to do more than this? We didn't give you the graph in one because of this, and I'd say you can do it without the calculator. What is this going to look like? Well, I'm going to give myself out a sketch. Here's my Cartesian plane. Is there an asymptote to show for this one? For 1. If I graph 1 over x squared, will it have an asymptote? We got one person. Fabulous. Fabulous. You can tell me there is going to be an asymptote. Wait for 4 of you. What value can't you get? And output 4. 2 of you? 3. We're getting there. We're getting there. 0. So I'm going to have a vertical asymptote there. Now, to figure out what the function is doing, think about the x's that you're plugging in. On the right-hand side, I'm going to start plugging in, are the values over here on the right-hand side, are they positive or negative? Positive. So what's 1 over 5 squared, or 1 over 25? Is that a positive number or a negative number? So as we approach this over here, this is really close to 0, and then it's going to ride up. Now think about plugging in from the other side. Negative 5. What's 1 over negative 5 squared? Well, what's negative 5 squared? 25. 1 over 25 is going to look just like it did on the other side. We'd have a graph that looks and trends like this. What is the limit as x goes to 0 going to be? If I say this, if it came up, I guess I would say I take either, or I give you instruction beforehand. And again, it all depends on, both answers are right. Why doesn't the limit exist? Because what's the value going to? Positive infinity. In order for a limit to exist, it has to convert to a number value. You have to be able to hold that many apples. That's the number test. Can you hold 1 billion apples? Yes. Can you hold infinity apples? No. So who the hell wants 1 billion apples? Now, let's take a look. The graph is given here. This is going to have a vertical asymptote at x is equal to -2. You know that because of the denominator. And sorry for bouncing over to 4. What's the value of that limit going to be? And this one is a definite. What would the value of this limit be? Maybe I'll start asking the floor spots. Yes. Why would infinity not be an acceptable answer here? Do you know why? And when it comes from the left, where's it going to? So are they going to the same infinity? No. They're diverging to different values. This next one up here, I go through and say, now you can graph this all you want to, but you need to understand, if I see something like this, you better be excited. Look at that numerator. Who can tell me what you can do to that numerator? We got 1, 2 people. I'm disgusted for those that I had last year. Disgusted. Do you know what this does? What you can do? What? You can, it rhymes with tractor. Yep, we can factor it down. So we have x minus 1 is the binomial. What are your signs going across going to be? Minus, plus, plus. Do you remember what the trinomial is going to be? Who remembers the trinomial factors? 2 people, 3 of you. Just wait. You're lucky that that printer was down this morning. Next time, you know what we're going to have? No mercy. All class. Enjoy your last day. You're like, oh, those first 3 days were so amazing. And then the cards came out. And then I hated it like I thought I would. What?
The other one. Well, you multiply those together, so like I don't know. I guess okay. And then one.
Okay. And it's over x minus 1. That means that this graph right now is going to have a hole in the graph where the factor that reduced out goes to 0. Shockingly, it's at 1, and that's where we're taking the limit. We can now evaluate this limit out, though, by direct sub. So I go over here. The limit is x approaches 1 of x squared, the related limit. That's going to give you an answer. Hands up, please, when you can tell me what that answer is going to be. Seriously? 3 people. Look out, MIT. I can't wait when I hear somebody goes, oh, I'm thinking about going to college. I don't want to ruin it. Everyone's going to say no. I'm going to call them up and be like, no, they don't participate in class. Don't take them. I'm going to call the college board. Throw out the SAT scores. They know nothing. They never answer anything in math class. Nothing. What do you want to say? 3. Okay. See, boy, that was tough. That was tough. Let's go over now. The limit is the tangent approaches pi over 2 from the positive side. So as we're looking at this is pi over 2. Now as I approach it from the positive side, what is that going to? By the way, this is a one-sided limit, which means positive and negative infinity is a valid answer. Who can tell me, please, what that's going to? Okay? Negative infinity is correct. And how about what's happening for 5? Hands up, please, if you can tell us for 5. Fabulous. Just what I was hoping. If you go through and you get 0 over 0, that means indeterminate form, you need to go through, maybe we'll write that out. Is it ITE or ATE?
ATE.
Indeterminate form? You're going to have to correct me if I know I'm going to start wrong all the time. Look to do some form of algebra manipulation. If it's a number over 0, you're going to have a vertical asymptote. 0 over 0 means there's a common factor that we can reduce out. Questions on that? Now, you all have 7 minutes left. You all should have our worksheet B on your desk. By the way, what's due next? What is due when we see each other at the beginning of class 7? Your Math Excel homework. It's only up to 30. Like up to that point. Not all of it. No, I know. You're going to keep going. You're going to hand just in your work. You understand what I'm saying? Okay. So that's the first thing. You're going to hand just your work. You don't need to finish everything. Not at all. The other thing that you're going to have, worksheet B, is due on day 8. Let's do one more thing before you go. What? Sure. You not having a calendar? No, well, terrific. All right, you did this already. Get my copy. What I wanted us to do, but I thought you'd get something out of it. Day 3, day 4. When you came in, you picked up this in worksheet B. Oh, here we go. I'll say this. We've got 5 minutes. That's actually enough time to get this done. Take a look, please, at what's here. There's 3 questions. Slide over, please, and pick this up. You can get this question done. We didn't get to it the other day. So go slide up here, please, and grab this. Get worksheet 3 done. It's 5 minutes. We'll give you a bunch to start on your own. Yes.
I already did 1.7, but I didn't write down like all ones for every question.
Give up if you're going to do that. I'm going to short the one from.
Do you want me to like go back through every question and like top work?
What do you need?
Like when I was
Well,
playing on my computer,
Okay, do you have the correct set and get your stuff out on?
only a couple of questions, because a lot of them I did and then I had to figure out. Let me go back through and.
We'll say that, give me enough to know that you didn't go through and copy. Okay? So, some of the questions, you can just do, I think the first 5 or 6 were like direct stuff. That, I don't need anything. But if it's something complicated, you know, that you type in your calculator that's a lot, or maybe you just give me the picture of whatever the calculator gave or whatever, just sketch that. Okay? Did you take my hand sanitizer?
Yeah, from last time.
That's so, you know what it is?
Hand sanitizer, and I was like, this isn't really easy.
And you're an AP Calc, right?
Yeah, unfortunately.
It's gonna be a long year. So I got your pre-soaked for the next time
Very
we
true.
wash it. Walk through these last two. I know you only had, there's 3 questions on this, so don't freak out. But the first 2, y'all should have been able to finish in this short amount of time. When would you use direct substitution? When the function's continuous at the value. You can just plug in and go through and determine the value. If it's not continuous is when we're going to have an issue. That's as succinct of an answer as you can give. Question, the next one up, question 2. Which one can be used to find the limit as it approaches 2? Well, which one shows me converging on 2? Is this tight enough here? Yes or no? No. Which is the best one that converges on 2? This is taking a very outside approach in. This is taking and converging on 0. This is getting there, sort of. This is really converging on what's happening. You are right next to a 2. Now the last one, you have to go through, you're given this, find the limit as x approaches 1 from the left-hand side. It's a piecewise function. Do you need to use both pieces? No. Which piece are you going to use when you come at it from the left? The negative one, which would be that top one there, you plug in. That's what the notation would look like. Your notation, by the way, you are going to lose so many points the first half of the year. You're going to think terrific work with terrible notation. All right? So see, I love it. We don't have enough time. You even have enough time for me to make fun of you. So we're going to ask you to do, let's make sure, turn your calculators over. See the number on the back? That's the calculator slot that it goes in on the side. Yeah. So if it's not in the right slot, you fix it and make it happen. See, all of the rage comes out. Just wait till I get some papers with the spaghettis on the side. Oh. I'll throw gas down those days.
God, bro. God.
What are we gonna do?
Yeah.
No, that was the one day.
No, it'll be the whole. Oh, I cannot go through.
No, that was
false. Yeah, Josh, it's 2 up on that. Yeah, Josh, you'll be all grabbing mine. I lost by like, you lost? JJ had Antonio Brown. And then
I feel like I lost all my time on
quarterback.
I'm long after.
Drew Brees.
What's happening? My guy got 30 seconds.
Yeah, Drew Brees also.
I did not have
13. I know. How do you know? Because I know it's like
You can tell me I stayed in
Probably here, hang on, I promise. Yeah, I agree.
Humanity.
Last guy? You got an email from your email. Okay?
Sam, you got it.
Sam was literally the worst. I'm not afraid of you.
His kicker got the more point.
I'm not afraid of you.
I love like acknowledging that I'm raising my hand and never call on me.
Because it's no fun to call on you if you're gonna get it right. I
Yeah,
like when
you
people
look
get it
at
wrong.
One person and you'll wait like hours.
I know. Can you hear the rage?